Our final section for this chapter will be the equations and examples for lenses. You should notice that these are the same equations that we used for mirrors. Nothing has changed except perhaps what quantities are going to be negative and which ones are going to be positive when we get our final answers. So as I mentioned, the plus and minus signs might be a little bit different from the mirrors. So what I've done is made a table and summarized everything for you. So on our radius of curvature and the focal length, these right here, if we have a converging mirror, remember converging is convex, both the radius and focal length will be positive numbers, and then if it's a diverging lens, which would be concave, they will be negative numbers. So remember, diverging is the one where it's thinner in the middle. And then for our image distance, the DI, if you are calculating and you see on your ray diagram that you get a real image, that should be a positive number for the DI, and then a negative number would indicate a virtual image. And then our image height, this is the same as mirrors. It's positive if it's upright and negative if it's inverted. So I've got two example problems for you. Let's go through these together. We have a 5 centimeter tall object, so that is going to be our HO. It is located 30 centimeters from a convex lens, so that's going to be our DO, and then our focal length will be 10 centimeters. So for part A, we're looking for the location of the image, which will be our image distance. So we set up the lens equation. 1 over F equals 1 over DO plus 1 over DI. And since we're looking for DI, I'm going to take this term and subtract it over. So that's going to leave me with 1 over DI equals 1 over F minus 1 over DO. And you can plug in your numbers and figure out DI from here. Hopefully you got a final answer of 15 centimeters. Now, you should have had some practice working with this formula before, and we talked about using the fractions and then taking the inverse at the end. I'm going to show you another shortcut on your calculator that you may not be aware of. So in this problem, I could use the x to the minus 1 key. So if I'm typing on my calculator, I could have said 10 and then hit the x to the minus 1 key, and it shows up like this on my calculator, and then say 30, and then hit the inverse key, the x to the minus 1, and it's going to look like that. And then after I hit enter, that's when I get that decimal number that's going to show up as 0.066 repeating. From there, all I have to do is hit the x to the minus 1 key again, and on the screen it's going to look like answer to the minus 1. So it's going to take this stored answer from the previous thing, and then when I hit enter, then I get my final number of 15, and then you can put the centimeters on when you write down the answer in your notes. So it's just another way to go about the problem. It saves you a couple of keystrokes, so you don't have to type in all of those parentheses and division signs. So it's really up to you. I just wanted to show you the other method. In part B, we're asked to find if the image is real or virtual. You can look back at that previous chart and see that if the image distance is positive, that is going to make it real. Okay, and then next we're asked to find the height of the image. So we're going to use that magnification formula just like we did in the last chapter. And it looks like this. We don't actually need the magnification, so I'm going to ignore this part and only use this section and then plug in my numbers and get the height of the image. So yours should look like this. You simply cross multiply and come up with the final answer. And remember, there is a negative sign that's part of the formula itself, so you want to make sure and include that. And that's going to make our image height equal to negative 2.5 centimeters. This also confirms that it was a real image because we have a negative image height, just like we did for mirrors. And then our last question asks if the image is inverted or upright. The answer is inverted because the image height was negative. And we also know that it's inverted because we answered that it was a real image earlier in the problem. So let's try one more. This time we'll be working with a concave lens. So we have a 1.25 centimeter tall object that's 4 centimeters from the lens, and the lens has a 6 centimeter focal length. Now remember earlier In that chart, it said a diverging lens has a negative focal length. A concave lens is diverging, so it's up to you to supply the negative sign on our focal length right here. In part A, we're asked to locate the image, so we're looking for DI, and then we're going to tell if it is real or virtual. So we'll set up our lens equation, and again, I'm going to subtract this term to the other side. Don't forget to include this negative sign in your focal length when you type that into your calculator. This gives us the answer of 1 over DI as negative 0.416, and don't forget you have to take the inverse of that to get the final answer of the image distance, and that tells us that it's 2.4 centimeters, and it is negative, so be sure to include that sign in your answer. Now, if you go back and look at that chart from earlier, a negative image height indicates that our image is going to be virtual. Now we can do part B. We're looking for the size of the image, so that would be the image height. And we're looking to see if it's inverted or upright. So we're going to go back to the formula that you should be familiar with. HI over HO equals negative DI over DO. And let's plug our numbers in and see what you get. Remember, there was a negative sign in the formula and our DI was negative, so those are going to cancel out with each other. So cross multiply, and you should get an image height of a positive 0.75 centimeters. Now don't forget, we were also asked if the image was inverted or upright. This one is upright. And we know that because the image height is positive, and we also know that because earlier we said it was a virtual image, and virtual images are upright. So I put together a summary for you. For the lens type, convex and concave, I tell you when the focal length should be positive or negative, and then this summarizes what you should have found when we did our ray diagrams. So it takes those pictures and it puts everything into one little chart for you. So on your test, I'm not going to ask you to fill in this chart, but it is a pretty good summary, and it does go hand in hand with the ray diagram worksheet. So just kind of take a look at those and compare them. And then also I summarized for you, I'm not sure if you noticed, but the real and virtual versus only virtual images produced for lenses are opposite to the mirrors. So our concave mirror gave us both real and virtual images, but only a convex lens can do both of those. And then when we studied mirrors, it was a convex mirror would always have a virtual image. And in the case of lenses, it's a concave lens that will produce only a virtual image. For this last section of your notes on the applications of lenses, you are actually responsible for this section. You're going to see some multiple choice questions come up on your test. So I gave you some guidelines and things that you want to make sure you can answer for each of the topics. So you'll research about the eye and define these terms and know the difference between nearsighted and farsightedness. Next, we have telescopes and binoculars. And you'll need to know what types of lenses are used for those and how many, and then which types of images are produced by those lenses. And finally, we look at cameras and microscopes. Again, you need to know what type of lens and how many are used in these devices, and then what type of images are produced as well. I'll give you a hint. If you do the extra credit for this chapter, the extra credit assignment will actually help you with these questions. So that's it for our refraction and lenses chapter, and good luck on the next test.